So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 19 of the Be Daily Lead Code Challenge. We have a graph question in front of us. Let us see what the question is. It's question 785, is graph bipartite? So this is the question, and if you see the input given to us, we are given just adjacency list, okay? If you're not aware about adjacency list, so it basically tells us which node, how the nodes are connected to each other, okay? For example, the one which you're seeing here, index 0, it says 1, 2, 3. That means the node 0 is connected to node 1, node 2, and node 3. Similarly, at the next one, we are seeing 0 and 2. That means the node 1 is connected to 0 and 2 node. Okay. And similarly, this one. Okay. So that means node 2 is connected to 0, 1, and 3. That is the basic idea. And let us see what, see the from the name of the question itself, we would have understood that there is called something called bipartite, and we have to check if the graph is bipartite or not. And obviously the answer is going to be a boolean one, either true or false. Okay. So yeah, that was all, and let us see now the detailed question. Okay. So they are saying it's an undirected graph. By now you would have understood that because you seeing the things are repeating here. Okay. So it's a undirected graph. There is no direction for edge with n nodes. Each node is numbered between 0 to n minus 1. You are given a 2D array graph where graph of u is an array of nodes that node u is adjacent to. More formally, for each v in the graph u, there is okay. So what it means is, see, the one which I told you is exactly the same. And let me just tell me one thing: how you will get n? Okay, because you are given just the graph nodes. Okay, on the adjacency list. So there is a very simple thing. You can just take the length of this particular list, and it will give you the length n. Okay, it will give you n. That is the basic idea. And there are some details given here. These are not very much needed for solving the question, so I will just skip them for now. Yeah, it's clearly mentioned the graph may not be connected one. So yeah, there is possibility that two nodes may not have any path between them. So they are mentioning that here. It's something important. And the other part is the graph is see, they have given the definition of bipartite here. Please pay attention to this definition, though it is not very understandable, but still you should have a, like, just try to understand as much as you can. Then we will try to understand through examples. Okay. A graph is bipartite if the nodes can be partitioned into two independent sets A and B, so that every edge in the graph connects a node in set A to a node in set B. Okay. Let's see what it means. Okay. See, you take any see, you take any edge. Okay. For example, the edge connecting 0 and 2. Okay. So always the nodes, see, for example, it connects 0 and 2. So 0 and 2 should be in a different group. What it means is, imagine there is, so just we will color the nodes. Okay. Just imagine like that. Imagine there is a color blue and there is a color red. Okay. So the every edge connecting two nodes, that means every edge should connect a node from a blue to a node in red. Okay. So that means 0 has to be red, let us say, then 2 has to be blue. Okay. I will take the example and show you how it works. That will be the, see, I have created two sets here. Okay. One is a set red, another set blue. Okay. You have to understand the definition of bipartite. You have to take this example. Okay. So what it means is that every edge should connect a node in set red to a node in set blue. Okay. So because let us see, go by edge 0 and 2. Okay. Or edge, okay, let us say 0 and 3. Okay. So I have to keep 0 in any one of them. Let me keep 0 in red. Okay. That doesn't matter. But once I declare 0 as red, 3 has to be blue. Okay. So I am keeping 3 here. Okay. I'll just increase the font size if you are not able to see. Yeah. Now it's better. So I've done for this edge. Now comes the edge 0 and 2. Okay. So already 0 is red. So 2 has to be blue. There is no option otherwise. Okay. Similarly for that 0 and 1. So 0 is, I have already declared it as red. So the 1 has to be blue. Okay. This is done for all edges. See, this part we have cleared now. Okay. 0 being connected to 1, 2, and 3. Now let us come to node 1. Okay. Node 1 is connected to node 0 and node 2. Okay. So yeah, here node 1 is connected to node 2 and node 0. So node 1 and node 2 should be different color, but we are seeing that node 1 and node 2 are in the same group. They're not having different colors. Okay. That means there is a issue here. This graph is not bipartite. Okay. That's why the answer is false. So just now again go to the definition of it. See, a graph is bipartite if the nodes can be partitioned into two different sets A and B, such that every, see, first part, if you did not follow, no issues, but this particular sentence is very important, such that every node in the graph connects a node in set A to a node in set B. They are calling it set. I am given two colors. Okay, red and blue. they are calling it this as set, but you can take a color also. Okay, so what it means is every edge present in the graph should connect a node from a red color. So that means the both ends of the every edge, okay, it should be red and blue only. That is the basic idea. But if you are seeing here, see, based on this particular thing, I defined it. Okay, when I come to this thing, that is node 1 being connected to 2, I can see that they both are having same color. That means the graph is not bipartite. That was a simple example. Now coming to the second example. See, ultimately, you just have to ensure that every node connect, every edge, okay, the connecting to a node, the two nodes are having different color. Okay. See, there can be only two colors. Okay, they are, that's why saying set A and set B. Okay, you cannot have a third color. Just have that in mind. Now coming to this example, again I will go with this. Okay, node 0 being connected to node 1 and node 3. Okay, so I will keep node 0 as red. Okay, it is connected to node 1 and node 3. So node 1 and node 3 should be the other color. Okay, yeah. Now coming to this, okay, node 1 is connected, okay, that's already done. Now coming to node 2, and node 2 is connected to node 3 and node 1, okay. So node 1 and node 3 are already blue, okay. You can see here node 1 and node 3 are already blue. That means node 2 has to be red, okay. It has to be red. Yeah, we have covered all the edges, okay. There's no edge remaining, okay. So you can clearly see in this case, we have a like division of sets here, okay. We can clearly see every edge is connecting a node with different colors. Okay, for example, every edge you can see, for example, this says kind of 0, 0 and 1. 0 is having a different color, 1 is having a different color. That means this particular scheme is possible, right? Here, partition is possible into sets. Okay, that's what I'm saying here. We can partition the nodes into two sets, 0 and 2, and 1 and 3. That's what I have done here. Okay, that means such a partition possible where each node is connecting nodes with different colors. Okay, here you can see the constraints is like 100. You can try for n square approach as well, and you can also follow the simple graph traversal algorithms. Okay. So now coming to solution, what we'll do is, see, here I'm going to follow the BFS approach. My approach is very, very simple here. What I will do is, see, whenever, see, first of all, I will go through each of the nodes. Once I select a node, I will allow the default color to it, okay? For example, let us say red. Once I will allow the default color to it. And for all its neighbors, I will allow the color blue, okay? Because my current node is having red, all its neighbors should be blue, okay? I will then insert them in a queue. That is what is BFS, right? Then I will, like, once their turn comes, their neighbors will be checked for the color. If they're uncolored, they will be colored the opposite color. Okay, that is how I will be doing. Once I find a node and its neighbor having the same color, I will turn false. That is going to be the basic idea of what I'm doing. Let us see how I'm coding it. So as I told you, if you have to get n, you have to take the length of the graph list given to us. Okay, I am defining see one thing. Let me make it very clear. See here, they are telling A and B. Okay, they are calling it as set A and set B. I am calling it as red and blue. But in code, you will see that I have done 1 and -1. Okay, so what is red is I am calling it as 1. Okay, let me write it in bracket. Red, I am calling it as 1, and blue, I am calling it as -1. Now you will ask me why I am doing that. Okay, so see, it's for basic simplicity. If I want to reverse the color, see, if a color is like if a node is having color 1 and I want to assign a color to its neighbor, so I can simply multiply it with -1 and I can assign it. Okay, that's what I'm doing here actually. It makes my job easier. Okay, so that's what I've done. Okay, no, see, whenever I say 1, it will refer to red color. Whenever I say -1, it will refer to blue color. And whenever I say 0, okay, whenever I say 0, it will refer to uncolored node. Okay, that is the basic idea. So see, this is my color array. This will be representing the color for each node. Okay. So initially all nodes are uncolored. So I will allow 0 for each of the nodes. Okay. This for loop will run for each and every node. Okay. Because see, they have clearly mentioned here there may be a case where the yeah, the graph is not fully connected, right? So we have to go through each of the like partitions here. It may not be connected. Okay. So we have to again go through each of the nodes. That's why this follow exists. What we are doing is if a node is already colored, we are not going to touch it again. Simply leave it. Okay. So just for this part you will understand when you will see the whole picture. Okay. When you will see the whole code, only then you will understand the bigger picture of it. But my real code starts from here. Okay. I picked an uncolored node I, and I'm going to color it as node color one. Okay. Color one means red. Okay. What I will do is I will start to BFS traversal out of it. So first I will insert that node in my queue. Okay, a node I is inserted in queue. Okay, this loop will run till the length of the queue is 0. Okay, what I'm doing, I'm popping that leftmost node out. I'm calling it as a node. So what I'm doing is I'm going through the neighbors of the current node. See, this is the neighbors of the current node. J represents every node which is a neighbor of the current node. Okay, if my neighboring node is uncolored. Just try to understand the bigger picture here. I have taken a node. I am coloring it first. Okay, I've colored it as red. Let us say 1 red. I am inserting into a queue. I will run this value till my queue is not empty. I am popping out the first node which I have inserted. I am calling it as a node. I am going through the neighbors of my current node. Okay, if their neighboring node is uncolored, if the neighboring node is uncolored, we color it with the reverse color. What that means is, if the color of my node is one, if my color of my node is one, I will reverse it. Okay, that means the see, because each edge should connect nodes of two different color, right? That's what I'm doing. I'm multiplying it with minus one. See, j is the neighbor of node. Okay, j is the neighbor of node. That's why its color should be minus 1 into the color of node. Okay, and then append j to the queue. That's what I'm doing it here. Okay, this is the case when my node is, that is the neighboring node is uncolored. Now coming to the case where my neighboring node is colored. Okay, what I'm checking is, I'm checking if their color is same, if the color of j is equal to the color of node. See, j and node are neighbors, they should not be having same color. If they are having same color, that means the graph is not bipartite. I've written false. If they are already having different colors, then it's fine, no need to do anything further. Okay, that is the basic idea. Remember one thing in this question, if you try to trace this program, one thing that will be difficult for you to trace without knowing this is, see, I am going to insert in my queue only if the node is uncolored initially. See, here I am coloring it, here I am coloring it, here it was uncolored. Okay, here it was uncolored. Okay, here I am coloring it, and here I am inserting into the queue. So remember one thing, the nodes will insert into the queue only if they are uncolored. Okay, if they are colored, I will not be touching them further. That's what I am doing here as well. Okay, now you will understand this bigger picture. If a node is colored, that means all it's in like adjacent nodes, everything like they are already like processed one. They are already into the queue and they are out of the queue, right? So I will not touch them again. I will only going for the nodes which are not already processed or which are not already colored. Okay, that is the basic idea here. So now, I think now you'll be understanding this. See, this can also be implemented using a stack, and there are many ways to do it. But what I've done is I've done the simplest way possible. This is using the BFS algorithm. See, why BFS means, see, BFS is the only one where you will be processing C. I will like process a node and then I will go for its neighbor. Okay, when it comes to DFS, I will going through the depth of it, not the breadth of it. Okay, that is what I did not like. That's why I went for the BFS. See, there are ways to solve it using DFS as well, but I felt this approach is more genuine and very suitable for this particular example, and this will be easier for you to understand as well. Okay, so if you are a beginner, let me tell you this very frankly. See, what bipattern means is that every edge should connect two nodes from different colors. Okay, there are only two colors allowed. That means, suppose there is color A and color B. That means a graph should connect a node from color A to a node in color B. If that is not happening, then the graph is not a bipartite one. Okay, so that is what we are doing here. We are what see here we are randomly routing a color to a node, and then we are trying to see if its neighboring nodes are having a different color or not. That is the basic idea here. Okay. So yeah, friend, that was all for today. See, because it's a BFS algorithm, I think you will be able to understand the time and space complexity of it. Okay, it's going to go of n plus a, where n is the number of nodes and e is the number of edges. And in terms of space complexity, because we are creating a color array, okay, so obviously it's going to go of n. So yeah, friend, that was all for today. This was a slightly simple question, but if you are not clear with what is bipartite, then see, one thing is there, they are not clearly defining it. Okay, in the example also they have not very clearly mentioned what these things are. Only if you are already knowing what a bipartite graph is, you will be able to understand this. So these knowledges are, see, whenever you see a different term, always try to record it somewhere so that it becomes like known to you, it becomes familiar to you, right? Because in terms of Leetcode, they will not give a detailed example one. Okay, in this type of questions are actually simpler, but if you don't understand what is bipartite and if you see the examples also not clear, then you may not be able to solve it. So yeah, friend, that was all for today. If you have any ask, please do comment below, and if you have a better approach, then also let me know and we can discuss further. Yeah, friend, that was all for today. Thanks a lot.